Okay, today's lesson is on solving inequalities. Okay, that means we're talking about, rather than equations, and you can see I've got an equation here, 3x plus 6 equals 12, and we solved that. We've been practicing those. I subtract my 6 from both sides, 3x is equal to 6, and then I divide by 3. And I come up with one solution. 6 divided by 3 is 2. So 2 is the only answer that can make this equality a true statement. So I know that x has to be 2. With inequalities, you'll notice we have, in this case, a greater than symbol. But we've got 4 different inequalities we deal with. We have these strict inequalities, greater than. We have a weaker inequality, which is greater than or equal to, or not as strict. And then we got less than and less than or equal to. But you need to recognize right away when you go to solve whether you're dealing with an equation, looking for, in this case, one answer, or an inequality, because inequalities tend to have more than one answer. So let's look at how we solve this inequality. We actually solve it exactly the same way. We subtract our 6, giving us 3x is greater than 6, and we divide by 3. And x is greater than 2 is what we end up with. So x is greater than 2 means that any number bigger than 2 will make this inequality true. Now the actual number 2 will not make it true. If you were to plug a 2 in for this x, you'd have 3 times 2 is 6, 6 plus 6 is 12, and 12 is not bigger than 12. So whatever we want to use for a solution would always have to be bigger than the number 2. Now, when we get a solution to an inequality, we frequently ask you to graph those solutions. So here's how you graph them. We just graph them on a number line. Okay, so there's a number line that I've drawn. I want to mark the point of interest, and that's the number 2. I also want to mark one number bigger, 3, and one number smaller, in this case, 1. So you really only need to show those 3 points, the number of interest, and then one number on each side. Smaller numbers on the left, bigger numbers as we go to the right. And to indicate that x is everybody bigger than 2 on your paper, this is what you do. You circle that breakpoint, the 2, and you point in the direction that the solutions are, or the numbers are, that are bigger than 2. So in this case, we point to the right. And so this indicates to us that any number bigger than 2 is a solution. And so our final answer would just be x is greater than 2 along with that graph right there. So you can see that solving inequalities is very similar to solving equations. There is a couple of exceptions to the methods we have to use, and you'll see that in the next example. So again, here we have another inequality. All right, we're going to attack it just like we would if this was an equation to start with. We want to simplify each side. So I'm going to simplify the left side. The right side is just a 10. We can't do anything with it. So let's go ahead and distribute this negative 2. So negative 2 times x is negative 2 times x, negative 2x, and negative 2 times 1 is negative 2. And plus our 4. Now let's look for any like terms now that we've gotten rid of the parentheses. And here we have 2 constants. One's negative 2, the other's 4. So those can be combined into a single number. So that's negative 2x, negative 2 plus 4 is 2. Okay, I've got all my variables on the left-hand side, and so now I want to move any numbers that are added or subtracted away. So I want to get rid of this positive 2 by using subtraction. And I am left with negative 2x, these just knock each other out, is less than 10 minus 2 is 8. Now, this is where you have to be very, very careful. Anytime when you're solving inequalities, if you ever have to if you divide or you multiply by a negative number while you're solving it, you must flip the inequality symbol. Okay, and that's very important because it will not be a true statement. You'll get an answer and you'll think your answer is just fine, but your answer will not be correct. And I can demonstrate why that is in just a moment. But for now, my next step in this problem to get x alone is I have to divide by a negative 2. So I am dividing by the negative 2, which means as I do my calculation, I have got to flip that inequality. So negative 2 over negative 2 is still 1. Nothing changes there. Here comes the flip of my inequality. It was pointed left, now it points right. And 8 divided by negative 2 is negative 4. So there are my solutions. All the x values that are bigger than negative 4 will make this inequality true. And so our graph again, we're going to mark negative 4 on it. Bigger than negative 4 is negative 3, and smaller than negative 4 is negative 5. I'm going to put an open circle at negative 4, and numbers that are bigger than negative 4, that would point to the right. And so there is my solutions. Okay, now let's explain why you have to flip over that inequalities, just like you were solving an equation. However, if you ever divide or multiply by a negative number, you got to flip the inequality symbol to keep it a true statement. Let's take just a nice true statement. 8 is bigger than 4. Okay, this is true. Now let's say I divide the left side by a negative, any number you want. Let me get that so it's normal again. I'm going to divide by a negative 2. But look what happens when I do that. 8 divided by negative 2 is negative 4. 4 divided by negative 2 is negative 2. If I leave that inequality pointing to the right, this is no longer a true statement. It's now become false because negative 4 is not bigger than negative 2. But when I divide by a negative, if I remember to flip that inequality, then the statement will still remain true. Okay? So anytime you divide by a negative, you have to flip the inequality to make sure you're still dealing with a true statement. Solve these equations. I've just got 2 examples left for you. This one, I haven't shown it yet, but I want to change the problem just a little bit so you can see how we deal with it. This right here just says greater than, but I want you to see how to solve one that is greater than or equal to. Now again, we solve these things just like equations. So we're going to do some distributing on the left-hand side to get rid of the parentheses. That gives me an 18x minus 3 is greater than or equal to 18 minus 3x. We've got no like terms on either side that I can simplify with, so we're just going to start putting all our x's on the left. So I'm going to add 3x to the right-hand side so that it cancels, which means I got to add 3x to the left-hand side. So now we are at 21x minus 3 is greater than or equal to 18. Now I'm going to take any numbers that are on the x side, in this case it's negative 3, and I'm going to undo that subtraction with addition. And I get to 21x is greater than or equal to 21. And my final step, I'm going to divide by a 21, a positive 21, so I don't have to flip the inequality. And I end up with x is greater than or equal to, and 21 divided by 21 is just 1. So it's not very unusual It's just very, very similar to an equation if we were to solve that. But let's look at how we graph this now. So I'm going to draw my number line. I'll mark the number 1. I'll mark a number bigger 2 and a number smaller 0. So my point of interest is right here at 1. But because it can be equal to 1, what you need to do is color in that circle to say, hey, my solutions include the number 1 and anybody that is bigger than 1. And there is what our solution looks like. The graph of the solutions, everybody bigger than or equal to 1, and then an inequality that tells us the same thing. Here's our last example. This one we'll notice we've got, in this case, a less than symbol, so it's pointing to the left. Still doesn't change the way we solve the problems. Okay, it just means we got to pay attention. So let's go ahead and start doing some distributing. Now on this left-hand side here, we distribute this negative to everybody. Think of this as 5x minus both of these things. So we got to do the opposite of everything that's inside the parentheses. It's like distributing a negative 1 to each. So as we distribute that negative 1, we're going to get 5x minus 1x and minus 2 is less than, we distribute our negative 5, it's negative 5 minus 5x plus 3. Now if you look on the left hand side here, we still have some like terms, so we want to squish those together. 5x, take away 1x, that's 4x. Minus 2 is less than, and on the right hand side I think we've got a couple of like terms as well. We've got this negative 5 and 3, so those can be squished together. Negative 5 plus 3 is negative 2. So we haven't moved anything from one side of the inequality to the other. All we've done is simplified each side. Now let's get all our x's on one side. I'm going to move my x's to the left. So I'm going to undo this negative 5x by adding 5x. And I'll do that to the other side as well. So now I'm at 9x. My minus 2 is less than negative 2. I'm going to get rid of the 2 on the left-hand side by undoing that subtraction. And I get 9x is less than negative 2 plus 2 is 0. And lastly, I divide by 9. Divided by a positive, so I do not have to flip the inequality. 0 divided by 9 is 0, so my answer is x is less than 0. So let's take a look at that number line solution that we're going to give. We're going to mark the 0, a number bigger 1, and a number smaller negative 1. Our point of interest is 0. It's an open circle because we don't want where it's equal to 0, we just want less than 0. And in this case, the numbers less than 0 are this way. And so our arrow has to point to the left. And in fact, something I'd like to point out, whenever you solve inequalities, as long as you get that x on the left-hand side of your final inequality statement, like x is less than 0, whichever direction your inequality points is the direction that your solutions will be on your number line. So look at the way the arrow points here and the way our inequality points. And so if you have your x on the left, that's always going to be true. Okay, just to review that one key important point, homework problems to try, get to it, and make sure you're ready for class tomorrow to bring your questions that you have.